All right, so today what we're doing is part 2 of completing the square. Our answers are going to look a little different today. Okay? You should have titled your notes 4-4 and maybe put the date on it. You should probably write b divided by 2 squared. Okay, when I look at this, I see it's in the wrong order. So let me just move this back to get it in standard form. We talked about standard form quite a bit when we did the quadratic formula. Okay, now it's in standard form. I'm going to punt that C over here. So they were trying to confuse us. I feel pretty sure they were wanting us to think that was the C, but it's not. That's the B. That's the B term. Okay, so I'm going to kind of mark that out. I'm going to move this down here. Okay, so x squared minus 16 equals negative 16. Okay, so we have a little bit of a blank spot here to put something better that's going to make this factor into doubles. Okay, and the way we figure that out is our b value is negative 16. Okay, so we do negative 16 divided by 2, and we square it. Negative 16 divided by 2 is negative 8, and we square it, and we say it's 64. So we are going to add 64 to both sides. Okay, now we factor this. Okay. So hopefully you wrote down some steps yesterday. We could do it here. Let's see. Move the C value. Figure out what b divided by 2 squared is. Then you add that to both sides, and then you factor. Okay, and then you rewrite it. Whoops, that's not right. Then you rewrite it where it's squared, and then you take the square root of both sides, and then you solve. Okay? Okay, so we need to factor this. Remember, it's going to be a double, so that makes it easy. It's going to be 6 times 6, 7 times 7, 8 times 8. What does multiply to 64 that adds to negative 16? It'd be 8 and 8, and notice I'm putting a negative because the b value is negative. Okay? Then what's 64 minus 16? 48. Okay, we don't want to see double, we just want 1. So we say x minus 8 squared is 48. Now we take the square root of both sides, and yesterday, right here was a perfect square. We had a 25, a 36, a 100. We had things like that. Today, those aren't perfect squares. We have to simplify that. So let's go over our perfect squares again. This might be a good time to write them down again. If you're in the classroom, you see them on the board, but if you're at home, you don't. The perfect squares are 1, and we really don't use him in this case. Okay, 4 because 2 times 2 is 4. 9 because 3 times 3 is 9. 16, that's 4 times 4. 25 is 5 times 5. 6 times 6 is 36. 7 times 7. 8 times 8. Almost messed up there. That's 64. If you can't read that, 64. 9 times 9. 10 times 10. 11 times 11, and 12 times 12. You should at least know those. Okay, what will 48 divide by that's one of these? And we want the highest number. 4 and 12 works, but 48 will divide by 16 and 3. Okay? And so kind of learn, for 48, use 16 and 3. Okay, so we have x minus 8. We have a plain old x minus 8. The squared and the square root kind of wash each other out. They are opposite inverses of each other. Okay? And then here we have a 4 times the square root of 3. And we're almost done, guys. I should have used the space over here. All we do here is we add 8 to both sides. And so we say 8 plus or minus, I should have put a plus or minus there, 4 times the square root of 3. On the next problem, I'll make it neater. I apologize about that. Okay, so that's your answer. You can't do anything else with that. Just leave it like that. Okay? Okay, let me do better on the next one with the work to make it a little neater. Okay, this one has the C value already moved. What I see that we need to do is kind of make a little space there for our new number. Okay? Our new term. The way we're going to figure out our new term is do b divided by 2 squared. B is 6. Okay? So 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. Okay? We're going to add 9 to both sides. We're going to factor, and it's going to be a double. I can do 9 and 4 real quick in my head. Okay, so it's going to be a double. What multiplies to 9 that adds to 6? That would be a 3 and a 3. Multiplies to 9 that adds to 6. Okay, so x plus 3 squared equals 13. I don't want to see double. I want to see just 1. Then we take the square root of both sides, and a square root and a squared washes each other out. They are inverse operations of each other. And we get just a plain old x plus 3 equals plus or minus the square root of 13. Guys, 13 is a prime number. There's only 13 times 1. So there's nothing else we can do to this 13. It will not divide by a perfect square. So we simply subtract 3. You say x equals negative 3 plus or minus the square root of 13, and you're done. Okay, so that one went a lot faster. Okay, let's do one more. Okay, so I see that I need to punt this 7 to the other side. Leave room for my new number. Okay, kind of getting the pattern down here, guys. Okay, 4, whoops, you won't be able to see that. 4 is our b, and we need to do b divided by 2 squared. 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. If you go too fast, you'll get yourself confused. So slow down. I was almost going too fast myself. So we add 4 to both sides. What multiplies to 4 that adds to 4? That would be a 2 and a 2. 2 times 2 is 4, but 2 plus 2 is also 4. So again, we don't want to see double, but we do, so we write it squared. We got to take the square root of both sides. And when we do that, we get plain old x plus 2 equals plus or minus the square root of 11. Subtract 2, and you're done. Okay? I kind of worked that fast, so if you're watching the video at home, you might want to pause it and write it, and pause it and write it. Okay? So that is the second day of completing the square.